Hello everyone, I am Dr. Kumar and today I am going to discuss about units and measurements. So this is indeed a very fundamental topics in physics, and I hope that most of you have learned about this topic in your school level. So let's begin. So before going to units and measurement, let's have a look on what is physics. That means what physics actually deal with, what kind of information it can provide us, why do we need to study physics. So these are the things we'll discuss very briefly here. So as we know that physics is the most basics of the science. It deals with the behavior and structure of the matter. So study of physics is basically the study of natural phenomena which is occurring around us. So physicists study the natural phenomena through mathematics, and from the mathematical results they try to interpret the physical phenomena. So the field of physics is usually divided into the areas of motions, fluid, heat, sounds, light, electricity and magnetism, which is referred to as classical physics, whereas the study of relativity, atomic structure, condensed matter physics, nuclear physics, elementary particles, astrophysics, so all these things belong to the modern physics. One important aspect of physics is observations of events, which includes the design and carrying out the experiments. Observations and careful experimentations and measurement are one side of the study of physics. The other side is the invention or creation of theories to explain and order the observations. The theories, it must be emphasized and not derived directly from the observations. Observations may help inspire a theory, and theories are accepted or rejected based on the observations and the experiment. Now let's talk about what are the physical quantities. So all the quantities that can be measured are called physical quantities. For example, length, mass, force, work done, etc. are called the physical quantities. Now when these physical quantities are compared with a standard physical quantities, that is called the measurement. And all the physical quantities are measured with respect to a standard magnitude of the same physical quantity, and these standards are called units. For example, second is the unit of time, meter is the unit of length, kilogram is the unit of mass, etc. Now the physical quantities can be divided into two types, that is fundamental or basic quantities and derived quantities. So the fundamental quantities are independent to each other. For example, mass, length, time, electric current, temperature, etc. Whereas the derived quantities are dependent to each other, and this can be represented in terms of the other quantities. For example, speed, volume, density, etc. For example, speed can be represented as the ratio between the distance and time. Therefore, since the derived quantities are expressed in terms of fundamental quantities, or we can write the derived quantities in terms of fundamental quantities, therefore these quantities are known as the derived quantities. Now there are 7 fundamental quantities, and these are length, mass, time, temperature, electric current, luminous intensity and amount of substance. So all the derived quantities are expressed from these 7 fundamental quantities. Now all the physical quantities, whether it is a fundamental or derived quantities, are expressed in terms of units. And there are a number of unit systems, and these are the common unit systems which are basically used in physics. In CGS unit system, the length is expressed in terms of centimeter, mass is expressed in terms of gram, and time is expressed in terms of second. Whereas in FPS system, the length is expressed in terms of foot, and then mass is expressed in terms of pound, and time is expressed in terms of second. Similarly, in MKS system, the length is expressed in terms of meter, mass is expressed in terms of kilogram, and time is expressed in terms of second. Whereas in SI system, it contains 7 fundamental units and 2 supplementary fundamental units. So basically all the units in MKS system and SI systems are almost similar. Therefore, in physics, all the physical quantities are expressed in terms of a numerical value and a unit. For example, suppose the length is expressed in 1 meter, 2 meter, 3 meter, whereas 1, 2, 3 are numerical values, whereas meter is the SI unit of the length. Similarly, the time is expressed in terms of 1 second, 2 seconds, or 1 hour, 2 hours, where 1, 2, 3, these are the numerical values, where second, hour, these are units. Now, what is dimension? So, when we speak of dimensions of a quantity, we are referring to the types of units or base quantities that matter. For example, the dimension of area is length square, and it can be written within the square bracket, that is L square, and its unit may be meter square, feet square, centimeter square, so on. Similarly, the volume can be expressed as length cube, and its units can be written as meter cube, feet cube, or centimeter cube, and so on. Now, the dimensional analysis can be applied to check the accuracy of the physical equations, to change the physical quantity from one system of units to another system of units, and to obtain a relation between different physical quantities.